Good afternoon, everyone. Thanks for coming. Thanks to the organizers for making this happen. I will talk about bioactives and how you can deliver them into the bloodstream, your body. Bioactives are typically things that are extracted from plants or mushrooms or other natural sources, and they have an effect on you. It could be therapeutic effect, like a medicine, a drug, and or it can have an effect that you can perceive. For example, cannabis, you can definitely perceive that. And other things like mitragynine or mitragynine, as some people call it, from Kratom, and basically medicinal compounds that are active biologically. And I will talk about a particular way of formulating them for delivery, specifically making them water soluble. Naturally, these things are, in most cases, not soluble in water, which makes it difficult to deliver to the bloodstream, which is water, and in general, we are mostly made of water. So when things don't dissolve in water, it makes it hard to bring them into the bloodstream. So I will talk about water-soluble formulations made from those compounds, how to do it, what the benefits are, and most importantly, how you can make your own without necessarily, having a PhD in chemistry. Cannabis is a good example. People typically know, and in many cases have personal experience with cannabis. So there are lots of different ways of bringing cannabis or cannabinoids extracted from cannabis into the bloodstream. You can use your lungs, so smoke it, vape it, dab it. You can consume it as an edible, digestibly. For example, as a brownie or a chocolate. You can use a mucous membrane to bring it in. For example, there's a mucous membrane under your tongue, and so some people put MCT oil drops under your tongue and that brings it in. Or you can attempt to bring it into the bloodstream through your skin, which is probably the least effective method of all. But the point is that all these methods coexist. And the question is, why is it that they coexist? Why not just use the same method? You don't do this with alcohol, right? You could vape alcohol. It would work. You could use sublingual drops. You could even have like a transdermal patch of alcohol, but why would you? You can just have a drink. And so the argument that I want to make in this talk is, you don't do this with alcohol because alcohol is one of those bioactives that dissolves in water. And when you make things, or when the things already are water soluble, there's really no problem in just making a beverage, and that is the best way and the most convenient way and the most discreet way. There's no smoke of bringing those bioactives into the bloodstream. So if you could make cannabinoids or other bioactives water soluble, then you could just have a drink. Or make something that becomes a beverage in a way. Let's say you could have a sublingual or chewable tablet that dissolves in your saliva and becomes like a saliva beverage. So that's what I'm going to focus on: how to make and why to make bioactives water soluble. Skipping way ahead, I can show you that it is possible. Specifically with cannabis, this is CBD, 20 milligrams per milliliter of CBD as a translucent liquid nanoemulsion. That is a powder. Both can go into water when they're formulated this way, and they go clear. Like this one goes completely clear. That one basically also. There's a slight haze to it, but you wouldn't really even know for this specific powder unless you compare clear water side by side. And that enables you to make beverages and a wide variety of other things like beverages. Now, a little bit about, I guess, basic physics of it. This is done by making formulations that are called nanoemulsions. Nanoemulsions are suspensions of tiny droplets in the nanometer range, let's say 20, 30 nanometers in diameter, that have a carrier oil, so that goes on the inside of the droplet. Oh, wow, that really moved it, yeah. So the carrier oil goes on the inside of the droplets. In that carrier oil, you have the bioactive dissolved. On the outside of each droplet, you have the formulation, so that would be something called surfactants. Typically, it's more than one surfactants that are balanced in such a way that gives you a stable set of droplets and minimizes their size. So this I'm going to talk about, how to do that later on in this talk. And then water is the outside of everything. And the droplets, there are typically also some preservatives because microorganisms also like cannabis, just like we do. So they will eat it up unless you put some preservatives in it. And then for this to qualify as a nanoemulsion, the size of these droplets has to be smaller than 250 nanometers. That is for it to be technically a nanoemulsion. Now, if you want this nanoemulsion to be translucent, like the one I showed in the previous slide, and for it to go transparent upon dilution, all the droplets have to be smaller than 100 nanometers, which means the D50, you're going to see it a few times, that's just the median of the distribution. Not exactly the center of it, but you can think of it as, roughly speaking, the average. So it has to be well under 100 nanometers. Ideally, the median would be between 20 and 40 nanometers, and there is a good reason for it, which I'll show you. Now, just kind of a side note, the word nanotechnology and I guess the science of nanotechnology is somewhat novel. Some aspects of it are really novel, and it's scary to some people in some contexts. And it's true that the nanotechnology is a quickly developing field, and lots of nanoparticles are brought into sort of our life. There are lots of things that are really interesting and can do lots of useful things, but they're not well studied yet, so we don't know what they do to us. For example, carbon nanotubes, buckyballs, or metal oxides, and things like that. On the other hand, nanoparticles themselves are not new. It's just that we pay them a lot more attention these days, and we develop new types of them. But nanoparticles have been everywhere as long as life has been around, and actually much earlier than that. For example, this is an everyday product, English breakfast tea, and this is a very typical droplet size distribution with the median of 25 nanometers. So it's extremely similar to good nanoemulsions that you would make from bioactives. This is McDonald's coffee. The coffee itself, I wouldn't say so great, but the nanoemulsion is really nice. A very tight distribution, 82 nanometer median droplet size. And this is a typical cannabis extract nanoemulsion. This particular one is CBD, the one I showed you previously. This is the droplet size distribution for it. Very similar to English breakfast tea, actually. And you can see that it's translucent, which is not the same thing as transparent. Translucent is like apple juice, let's say. You can see it, but you can also see through it. It's not completely clear like water. But once you dose it into water, it goes completely transparent. So you can see the dropper inside here. Now, this is a powder. It's one of our premium powders. This is a 35, roughly, nanometer droplet size upon reconstitution. So you take this powder, put it in water, it'll form a liquid nanoemulsion. So now it becomes a beverage, if that's how you want to consume it. Or you can make a tablet out of it, put it in the protein mix, instant coffee, whatever. So this is a droplet size distribution for it as well. Now, those were examples with cannabis. I want to show you what you could do with other bioactives. For example, this is mitragynine from Kratom. Some people call it mitragynine from Kratom. Nobody knows how to say it right, at least I don't. But somehow I think mitragynine is probably the right way to go. So let's do that. Do you guys know what Kratom is? Or Kratom? It's a coffee family plant, kind of like a cousin, but it produces this bioactive mitragynine, which is an upper in relatively small doses. When you dose it a lot higher, it becomes kind of a downer, and it's somewhat similar to morphine. It's an opiate family bioactive, but it doesn't have the same addiction issues. But it does have some of the issues of opiates. If you take it every day for repeatedly large doses, then you will get addicted to it. Although it's not a very strong addiction, apparently. But it's very therapeutically useful as far as getting people off other things. So alcoholics, even heroin addicts, they can replace it, and then getting rid of the addiction for this is much easier. So it's kind of like an in-between step. And it has lots of other therapeutic benefits. It grows in Southeast Asia, and apparently lots of people use it for just work. Probably not the best idea, because then you do it every day, but like construction workers apparently use it a lot. It makes you not feel pain, not feel tired, it lets you go through the day. Anyway, the issue with it is that it's not water soluble. And so when you consume it, and by the way, it's completely legal. I think there's a few states in the US, like 3 or 4 states where it's not, but it's legal everywhere else. It's legal on the federal level, you can ship it internationally, whatever. There are cafes where you can just go get it. But when you consume it, they take this plant, the leaves, and they make a powder, and they make like a horribly bitter, disgusting slurry from it, and that's what you swallow. And then, because besides mitragynine, which is what you want, there's all kinds of other stuff in it that you don't want, and people have upset stomach issues and whatever. Apparently it's still worth it, but if you didn't have that, if you could just make a normal, attractive beverage from it, then that would be much preferable. So the issue is that mitragynine doesn't dissolve in water. It dissolves slightly in acidic water, but it's unstable in it, so you can't really make beverages like that. It'll die on you overnight, basically. And it's not soluble in basic water. But you can make a nanoemulsion out of it by making it even less water soluble, but more oil soluble, dissolving it in oil and formulating it like I showed you previously. So this is a nanoemulsion with about 46 nanometers droplet size. That was the first generation. Now it's challenging to do this. I don't actually know of anyone else other than us that does it. But we also have the second generation product for this, and that is a powder where the droplet size is smaller than a nanometer. We can't even measure it. It worked out really well. And it's completely water soluble, so that you can make, for example, effervescent tablets from it. You drop it in water, it fizzes and gets you a beverage. We have some at our booth. What's our booth number? What was that? 2857. And this is what it looks like when you dissolve the extract in water. So this is our formulation, and this is a regular Kratom extract. So you can see that ours dissolves completely, and this just doesn't. Now, this is new data that I want to share with you. This is for the first time. This data was recently collected and processed, and there's going to be a paper coming out of it on this in one of the major pharmaceutical journals. I can't give details because it didn't come out yet, but here's the data. I already can share it. So we compared a translucent liquid nanoemulsion and a powdered nanoemulsion of delta 8 THC. Do you guys know what delta 8 THC is? Yeah. So it basically acts like THC, but it's legal because there's a farm bill that kind of lets you go around whatever made delta 9 illegal. It's not a Schedule 1. It's an unscheduled substance. So we compared the nanoemulsion, the liquid nanoemulsion, the powdered nanoemulsion, with MCT oil solution, which is how a lot of people, I would say most people, when they consume it digestively, that's how they do it. This is a pharmacokinetics study, which means we're studying the timing and the efficiency, basically, of how this arrives in your bloodstream. So, the blue line is MCT oil solution. Now, this study was made in a way that maximizes the bioavailability, which is how much you're going to bring into the bloodstream, regardless of when. It's just how much is going to arrive there versus go to waste. So we did it on with the subjects on the full stomach, which makes edibles hit you harder. I think anyone who's ever had an edible knows that if you have to eat something fatty. There's a reason for it. I'll explain why that is. But if you eat something fatty, then it hits you a lot more than if you didn't. So this study was done in kind of the worst case scenario for nanoemulsions, because we wanted like an honest test that we can report in a proper way. So the blue line is MCT oil solution. Now, you can see that for the first 2 hours, there's absolutely nothing. This is the vertical is the concentration in the bloodstream. So for, I would say, almost 3 hours, there's nothing. But after about 2 hours, you can start to feel it. This was on rats, by the way. It's preclinical trial. Okay, so the timing is not exactly like it would be for humans, but the relative measurement, comparing one thing to another, is relevant. Now, this maximizes after 6 hours. And it's important to point out that if it's a bioactive that's going to do something, for example, something medicinal, think of, I don't know, Tylenol or Advil. Your head hurts, you take it, and it works 6 hours later. That's not gonna be very good for you. You want the effect to be 5 minutes, 10 minutes, okay, at least to start. And then you want it to be at its maximum in half an hour, 40 minutes or so. Because otherwise, it defeats the purpose. And you want it to last for a reasonable period of time, 2-3 hours maybe. And then, well, if you need another one, you can take another one. But the problem with this kind of timing is not only is it super delayed, but it also is very inconsistent. It depends on what you ate, when you ate, details of basically your microenvironment in the digestive tract. And another thing that happens, especially with cannabis consumers, is you take an edible, an hour and a half later, you feel like you didn't take enough. Then you take another one. But then it turns out that you took enough. It's just not there yet. And then both doses arrive 6 hours later, and then you're somewhere in space. Now, you want to be able to titrate your dose. That's what you do with alcohol. I mean, if you know how to stop. Not everybody does, but at least they have the information that they would need to stop. That's their decision. So, nanoemulsions. The green is the powder, reconstituted in water. Same dose, obviously, for all three. Green is the powder, the red is the liquid, and you can see that about 10 minutes later, even less, I think it was something like 6.5 minutes, it's clearly detectable, you can feel it. Half an hour later or so, it's at the maximum. Then it stays for about 2.5 hours, let's say, maybe 3 hours. After that, it goes out. 6 hours later, it's gone. So you can titrate your dose, and you can receive the benefit, whatever it is that you took it for, in a reasonable amount of time. Specifically, within the first hour, which is what you want, nanoemulsions outperform MCT oil solution, basically outperform a traditional digestive administration method, an edible, by a factor of 19 and 16 or 15 and a half or so for powders and liquids, nanoemulsions. Even within the first 4 hours, it's 4 and 3.5 times greater. Just for the sense of perspective. So,
Theater 2, booth 55.
Now, this is another set of data for THC, regular delta 9 THC. The blue line is THC dissolved in MCT oil. Now this is on humans. So MCT oil on the full stomach. You can see it basically is delayed just like the other one, about 4 hours. So for humans it's a little faster. Now the red is also MCT, but on an empty stomach. And you can see that it comes in a little faster, but then it doesn't go anywhere. It just kind of comes in and then it starts to disappear on you. And this wasn't, I guess, wasn't the way that you would classically do it, but it was a self-reported high study, so we weren't very rigorous about the study. And it gave us an interesting insight. So at this point, about here, everyone just started to complain that they're really hungry, and we allowed them to eat. And guess what happened? Because on an empty stomach it doesn't really go in, but on the full it does. Apparently it sits there and waits. And so we let people eat and they came in. A little bit delayed, but here it is 4 hours later, okay? Now, nanoemulsions. Empty stomach and full stomach. Same timing as before. It's all the way up in about half an hour. You can feel it after 5 minutes. It stays flat, same thing here. And then 2 hours later it starts to go away. 3 hours later it's mostly gone. 4 hours later it's completely gone. The purple line is the same on the full stomach. It's slightly delayed because something called gastric emptying. Gastric emptying is basically in the stomach you sit and wait your turn to empty into the small intestine, hence the delay. But not much affected by the food at all. So nanoemulsions make it independent, but it's interesting that it's opposite of alcohol. So alcohol acts less on the full stomach. Nanoemulsions of cannabis act, I would say, a little more, although this difference might just be experimental error. Okay, now very quickly, why does that happen? So when you consume oil, triglycerides, basically fat or vegetable oil, it arrives in your small intestine as kind of like a blob. It can't mix with water, it doesn't dissolve in water, so it can't really travel through water, and something called unstirred aqueous layer, which lines the inside of your intestine. So it can't really get absorbed because it can't get across that water layer. Now, your gallbladder and your pancreas release lipases, which are enzymes that come in and basically clip a glycerin group of triglycerides. Long story short, in combination with some phospholipids and bile salts, which are surfactant-like entities, lipases create something called mixed micelles. Mixed micelles is a suspension of droplets of approximately 10 to 30 nanometers in size. They're the same as nanoemulsions. Now, this process takes about an hour and a half to even get started, about an hour, let's say, to get started, and it starts to really go after about an hour and a half or so. That's where the delay comes from. Now, it's important that these things, when they get across the mucus unstirred aqueous layer, they get to the inner surface of your small intestine, which is lined with something called enterocyte cells. These are absorption cells that will bring the stuff into the bloodstream. And they have these protrusions, kind of like fingers, of 100 nanometer in cross-section. And the space between them is also about 100 nanometers. So for you to be absorbed as a droplet efficiently, you have to fit in between here. That's the reason that smaller than 100 nanometers, or at least somewhere around there, really improves the delivery of whatever you have in the droplets. So importantly, nanoemulsions are basically that. And that's why they work so quickly, because you skip this entire process, they're ready to go. And you don't really need food, because for this to happen, you actually need triglycerides, you actually need food in the form of fat or vegetable oils. Now, importantly, how can you make your own if you would like to? So this is what our company does. We enable our clients to make their own nanoemulsions of not only cannabis, but pretty much any bioactives in the form of powders or liquids. And they don't have to have any technical expertise or chemistry background or physics background. They just have to have some basic common sense and be able to follow instructions. So we provide very clear step-by-step instructions to do that. There are three types of, so you need two things to make this happen. You need an ultrasonic processor. I'll talk a little bit more about them. So this is a piece of hardware that creates the droplets by shear force. So it creates something called ultrasonic cavitation, which in turn creates tiny microjets that hit oil droplets and break them up into smaller size particles. But that's not enough. You also need the formulation that will keep those droplets stable and will assist in making them the right size. And those are called nanostabilizers. So we created a whole line of nanostabilizer products, which are all-in-one formulations. They have everything that you would need. You don't have to go through any development for most bioactives. And they work with any of our processors. And in many cases, they're organic. In some cases, they're definitely always food grade, and they're completely tasteless, which is important because surfactants are actually pretty nasty tasting if you don't go through the development process correctly and you don't choose the right ones. A little more about our processors. So we do this on 3 levels. This is a lab scale system for process development. It will make about a liter of nanoemulsion per hour, which at the most common concentration is about 5,000 doses. So you can make quite a lot, but it's not a 24/7 type system. This is the smallest 24/7 kind of small production system. We call it bench scale processor, BSP 1200. It's 5 times faster, so you can make 25,000 nanomulsified doses of, let's say, THC, CBD, Delta 8, whatever. And this is our industrial processor, ISP 3600. It can make up to 100,000 doses an hour, which is a lot. So typically people who make THC products work with these processors unless they're very large. And that's because you can't transport THC-containing products across state lines. So if you're a multi-state operator, you would have to set production up in every state where you're operating, and this is typically enough, or in many cases it is enough. But for CBD products or Delta 8 that you can ship anywhere you want, people typically go with this because you can just set up shop in one place, produce a lot, and ship it everywhere in the world. A little bit about nanostabilizers themselves. This is called NanoStabilizer LT. Did something change with the sound? Oh, I'm sorry, okay. You guys can hear me, right? Yep. So, NanoStabilizer LT, this leads to liquid translucent nanoemulsions. All pre-mixed for you, easy to work with. It's kind of like it has the consistency of butter. You melt it a little bit and it becomes a liquid. You dissolve your cannabis extract or other bioactive in it, then add it to water and process and get the nanoemulsion. Mild, tasteless, food-grade surfactants. This is NanoStabilizer LSO, which is a fully organic formulation that leads to powders. So you can make a liquid nanoemulsion from it. It's going to look like skim milk. So not translucent, kind of white, but not very heavy white. But the advantage here, the main advantage is that you can dry it just directly and then grind it into a powder. So you can make powdered formulations this way. It also has some bitter blocking built into it. Some active extracts are bitter by nature, and this will help with the bitterness. Now a little bit more about the bitterness. It's a very typical thing to worry about. So bitterness mainly comes from the extracts. In the case of cannabis, it definitely comes from the extract itself. But you can minimize that by cleaning up your extract. So the extracts that have THC or CBD also typically have other things. And CBD and THC have bitterness to them, but other things like waxes, for example, and many other things that are co-extracted are much more bitter. So if you get rid of them by something called winterization, it really helps. Now, there's some amplification due to making these things water soluble, due to the droplet size reduction. They become more bioavailable, but also to your taste buds. So you can sometimes put a cannabis extract on your tongue and you don't feel anything, but that's just because it's not bioavailable to you. But if you make that bioavailable, it starts to be bitter. And very importantly, when the formulation is not right, it adds a lot of bitterness and just nastiness, soapiness, and whatnot. So what can you do? Well, clean up your extract or dress it up. For example, if you put it in with coffee flavor, your brain doesn't perceive bitterness as a problem because coffee is naturally bitter and your brain doesn't feel like it's tricked. It's kind of a more welcome bitterness. Or you can put it in non-alcoholic beer where you don't feel it. You can use a tasteless formulation, and definitely don't over-concentrate it. So taking that emulsion and putting it straight in your mouth is probably not a good idea. Why would you? You can put it in some water, dilute it, and drink it that way. And if you run out of options, then another thing you can do is use a bitter blocker. We offer bitter blockers. They're not 100% type solution, but in addition to other things, they work very well. So in the end, you can end up with a very pleasant tasting formulation. Lastly, we can make these things for you. We produce translucent liquid nanoemulsions with NanoStabilizer LT or powders with NanoStabilizer LSO. In addition, we make premium powders using a NanoStabilizer that we don't offer on its own. It's called LST. It makes powders that reconstitute into very, very small droplets. In some special cases, it's important. They go completely clear. So we can use that if that's what you want. We can also make Kratom mitragynine extract nanoemulsions, berberine for blood pressure reduction. By the way, it's an excellent alternative to metformin, a natural one. Metformin is a diabetes medicine. And lots of other things, piperine, coenzyme Q10, whatever. So if there's any need for any of this, let us know. And with this, I thank you for your attention, and I'll take questions.
So about buying edibles
Sorry, I can't.
About buying edibles at a shop.
Yeah.
Like, how many people are using your technology right now?
I would say last year we sold to probably 300 companies, just in the US alone and in Canada. And they're all producing because we can tell they buy NanoStabilizer. So somebody's drinking all this. So I would say a lot of, so when you see a cannabis beverage, it's probably made with this. When you see a cannabis powder, like an instant powder or something that dissolves in water, let's say an effervescent tablet or chewable tablet, or part of like a protein mix that has cannabis or lots of other bioactives, it's also likely that it's with this. Yes.
How do they dry these products?
So the nanoemulsions made with NanoStabilizer LSO, when you make them, they're milky white, like skim milk, and then you can use pretty much any drying technique you want. Spray drying is the most common, but it's not the cheapest. So freeze drying would work. Frankly, you can just dry it in the dehydrator. Yes. So if you are interested in making terpene water-soluble powders, then you have to be careful about how you dry it, because terpenes are volatile, and if you're going to lose some of them with water. So there are lots of different ways of being smart about it. You can do simple things like overload and then just live with some loss, if that's okay. Like, it's just economics, right? Or you can do something more complicated. For example, there are some membranes that you can use that don't let terpenes through, but they do let water through. It's a hydrophilic, hydrophobic type thing. And so you build up the partial pressure of terpene within the thing that you're drying, and then there's no loss. But it's more complicated. It's not 100%. Or you just try different methods. Freeze drying has advantages sometimes. Spray drying, when you do it quickly, sometimes has advantages. Thin layer versus thick layer if you dry it in a tray, things like that. But yeah, it's not trivial. All right, thank you guys.